Hello students. In this video we will solve remaining questions of exercise 15.1. In previous video we have solved up to question number 13. Now we will start from question number 14. So what is the question 14? Says one card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red color, a face card, a red face card, the jack of hearts, a spade, the queen of diamonds. Now all you know the total number of favorable outcomes. How many cards are there? Already given is 52 cards. Okay. Now for first a king of red color. Now there are two suites of red colors, that means diamond and heart. Each suite contains one king. Therefore, how many kings? Red kings? 2. So for favorable outcome for us, 2. Hence, probability of getting a king of red color is 2 upon 52. Number of favorable outcome to the event upon total number of outcome. After solving we get 1 upon 26. Now come to the second of face card. You know there are 12 face card in a pack, 3 for each suite. Therefore favorable outcomes 12, hence probability of a face card 12 upon 52, 3 upon 13. Next a red face card. There are two suits of red cards, that means diamond and heart. Each suite contains 3 face card. Therefore favorable outcome 3 into 2, 6. Hence probability of getting a red face card is 6 upon 52, 3 upon 26. Fourth, what is the probability of getting the jack of hearts? There are only one jack of heart. Therefore favorable outcome for our event is 1. Hence probability of getting a jack of hearts is 1 upon 52. Fifth, spade. There are 13 cards of spade. Hence favorable outcomes 13. Therefore probability of a spade is 13 upon 52, 1 upon 4. Favorable outcome to the event upon total outcome. Sixth, what is the probability of queen of diamonds? There is only one queen of diamonds. Therefore favorable outcome 1. Hence probability of the queen of diamond is 1 upon 52. This is question number 14. Now come to the question number 15. It says 5 cards, then 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. Okay, faces को उल्टा रखा गया है. One card is then picked up at random. Okay, what we have to find? We have to find what is the probability that the card is the queen. We know that total number of favorable, how many cards are there? 10, jack, queen, king and ace, 5. For first, there is only one queen, therefore favorable outcome for us is 1. Hence probability of the queen 1 upon 5. Second, if the queen is drawn, queen को निकाल लिया and put aside, side में रख दिया. What is the probability that the second card picked up is an ace? In this situation, the total number of favorable outcomes is 4 other than queen, and favorable outcome 1, and ace, there is only one ace. Hence probability of getting an ace is 1 upon 4. B part, a queen. There is no card as queen because we put the queen as aside. Hence favorable outcome for this condition 0. Therefore probability of getting queen 0 upon 4, 0. Clear? Now therefore can you tell me what is the impossible event here? What is the probability of impossible event? Probability of impossible event is 0. Clear? There is no favorable condition or favorable outcome. Now question number 16. 12 defective pens are accidentally mixed with 132 good pens. Clear? Therefore, total pens 132 plus 12, 144. It is not possible to just look at a pen and tell whether or not it is defective. इतना possible नहीं है कि देख के हम बता सके वो defective है नहीं है. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Again, total number of favorable outcome 132 good pen plus 12 defective, that means total 144. Now number of favorable outcomes is 132. We have to find the probability of getting a good one, and how many good pen are 132. Therefore probability of getting a good pen is 132 upon 144 after solving 11 upon 12. Now question number 17. A lot of 20 bulbs contains 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? How many bulbs? 20. Therefore total number of favorable outcomes 20. Number of favorable outcomes 4. We have to find the probability of defective. How many defective are there? 4. Therefore probability of getting a defective bulb 4 upon 20. Simplify 1 upon 5. Second part of question number 17. Suppose the bulb drawn in first is not defective and it is not replaced. That means defective नहीं था, good था और उसको replace नहीं किया. Now one bulb is drawn at random from the rest remaining bulbs में से. What is the probability that this bulb is not defective? Now the total number of favorable outcome 20 minus 1, because we not replace the bulb which we drawn, therefore 20 minus 1 19. Hence number of favorable outcome this time 19 minus 4. Why we subtract 4? Because we have to find the probability of not defective, so we subtract the defective bulbs. The total favorable outcome 15. Hence probability of getting a non-defective bulb now, when we put a bulb aside, 15 upon 19. Question number 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a a 2-digit number. The first, total number of favorable outcomes 90. There are 1 to 90 discs. Okay. Number of 2-digit numbers from 1 to 90 are 90 minus 9. We subtract 1, 2, 3, 4, 5 up. Total 9 number 1 digit, remaining are 2 digit 81. Therefore favorable outcome for this event 81. Why? Because we have to find the probability of a 2-digit number. Hence probability of getting a disc bearing a 2-digit number 81 upon 90. After simplification we get 9 upon 10. What is the second question? We have to find the probability of a perfect square number. Therefore we have to find the perfect square number between 1 to 90. These are 1, 4, 9, 16, 25, 36, 49, 64 and 81. These are in numbers 9, and probability of getting a perfect square is 9 upon 90, 1 upon 10. Third part of question number 18 is, what is the probability of a number divisible by 5? In this case we have to find the number divisible by 5 from 1 to 90 are 18. 90 upon 18, 18 5s are 90. The favorable outcome 18, hence probability of getting a number divisible by 5 18 upon 90. Favorable outcome upon total outcome is equal to 1 upon 5. Now come to the question number 9. A child has a die whose 6 faces, so the letters are given below. A, B, C, D, E, A. That means this time there is no numbering, only one, A, B, C, D. 6 faces represent these alphabets. The die is thrown once. What is the probability of getting first? A. Therefore total number of favorable outcomes 6. Number of favorable outcomes, how many A is there? 1 and 2. 2. Getting a letter A, 2 upon 6, 1 upon 3. Second, D. There is only one D. The favorable outcome 1. Probability of getting D 1 upon 6. Now come to the question number 20. Suppose you drop a die at random on the rectangular region shown in the figure given on the next page. Here, what is the probability that it will land inside the circle with diameter 1 meter? So therefore, this area is our favorable. If we throw a dice, if the die drop in it, we win the match, or we have to find the probability of. So first of all, total area. Why? Because total favorable condition of rectangle 33 into length into width 6 meters square. Area of a circle pi r square, pi into 1 upon 2, diameter is 1, the radius is 1 upon 2 square, pi upon 4 meters square. Therefore, probability of die to land inside the circle is favorable. Area pi upon 4 upon total area 6, pi upon 24. A lot consists of, question number 21, 144 ball pens of which 20 are defective and the others are good. Nuri will buy a pen if it is good but will not buy if it is defective. Okay, अच्छा है तो परचेज करेगी, अदरवाइज नहीं करेगी. The shopkeeper draws one pen at random and gives it to her. एक पेन उठाया उसने दे दिया. What is the probability that she will buy? When will she buy? When the pen is good. Therefore, we have to find the probability of a good pen. The total number of favorable outcome 144. Out of which 20 are defective. Therefore, non-defective pen will be 144 minus 20, 124. The number of favorable outcomes 124. Therefore, probability of C will buy, that means probability of a non-defective pen 124 upon 144. C will not buy when C get defective pen. Therefore, we have to find the probability of defective pen. The number of favorable outcome 20. How many defective pens? 20. The probability if C will not buy, that means probability of a defective pen 20 upon 144, 5 upon 36. 22. Refer to example 13, which state 2 die, 1 blue and 1 grey are thrown at the same time. Write down all the possible outcomes. First, complete the following table. Event of 2 dice, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Sum of, what is there? Sum of 2 dice, probability. Now, 1 upon 36, therefore 1, 1. When we get 1, 1, sum of these two, 2. Only one favorable condition, 1 upon 36, 12, 6, 6. The total favorable outcomes throwing 2 dice are, as we see in example 13, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3. How many? We get 36 favorable outcomes. Okay. We have to fill this table. Now, favorable outcomes getting the sum as 3. 2 is already given. We have to find the probability of getting sum of 3. Now, favorable outcome getting 3, 1, 1, 1, 2 and 2, 1. Only 2 possibility. 2 upon 36. Similarly, favorable outcome getting the sum as 4. 1, 3, 2, 2, 3, 1, 1, 2, 3. 3 upon 36, 1 upon 2. Similarly, you can find for getting a sum as 5, 1, 4, 2, 3, 3, 2, 4, 1. How many? 4. 4 upon 36, 1 upon 9. Favorable outcome getting the sum as 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. How many? 5. So 5 upon 36. Favorable getting sum as 7. Total 6. 6 upon 36. Similarly, sum as 9. 4. 4 upon 36. Favorable outcomes of getting the sum is 10. How many? 3 only. 4, 6, 6, 4 and 5, 5. The 3 upon 36, 1 upon 12. Favorable outcome getting sum as 11, which is 2. Hence P getting the sum as 11, 2 upon 36, 1 upon 18. We will fill the table in this way. Clear? Now, next, second part. A student argues that there are 11 possible outcomes: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability (1 upon 11). Sorry, miss. Do you agree with this argument? I do not agree with the argument given here. Justification already been given part first. The probability is 2 upon 36, 3 upon 36. Okay. Now, question number 23. A game consists of tossing a 1 rupee coin 3 times and nothing its outcome each time. Noting. Hanif wins if all the tosses give the same result. That means 3 heads, 3 tails. All loses otherwise. इसके अलावा अगर कोई आता है तो calculate the probability that Hanif will lose the game. The total outcome associated with the experiment 3 times. H all heads, 2 head, 1 tail, 1 head, first head, फिर tail, फिर head. इस तरह से अपने पास कितने आएंगे total 8. 2 to the power 3. Number of favorable outcomes 6. When he lose only 2 times H and T. That will 8 minus 2. 6 times he will lose. The required probability 6 upon 8. 3 upon 4. Now come to the question number 24. A die is thrown twice. What is the probability that 5 will not come up either time, and second 5 will come at least once? The outcomes associated with the experiment in which a die is thrown is twice: 1 1, 1 2, 1 3, 1 4, 1 5 up to 36. First throw shows 5 and B second throw shows 5. Therefore, the number of favorable outcomes 6 in each case. First shows 5, second throw shows 5. 5, 5, 5, 5, 6. Okay. Therefore, probability of getting P of A 6 upon 36, P of B 6 upon 36. Now P of not A is 1 minus P of E, which is 1 minus 6 upon 36, 30 upon 36, we get 5 upon 6. And P of not B 1 minus 6 upon 36, what we get? 5 upon 6. Therefore required probability is 5 upon 6 into 5 upon 6. 5 will not come either time. Okay, first time not getting 5 on 6, second time not getting 5 on 6, 25 on 36. Let S be the sample space associated with the random experiment of throwing a dice twice. Then N of S, total number of sample space 36. And then in the first and second throw shows 5 both times. So A intersection B, this symbol is known as intersection, common in both set. Getting 5 in each throw. We have 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, 1 5, 2 5, 3 5, 4 5, 5 5, 6. Only 5 comma 5 is common. That means both time we get 5. 1 upon 36 P of A already find, 6 upon 36 P of B already calculate, 6 upon 36. Required probability, once of the two throws shows 5 is P of A union, either one. This symbol is used for union. You will study in class 11th. P of A plus P of B minus P of A intersection B. This is the formula for this. 6 upon 36, 6 upon 36 minus 1 upon 36, we get 11 upon 36. Now last question of this exercise. Which of the following arguments are correct and which are not correct? Give reasons for your answer. First, if 2 coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, or 1 of each. For each of these outcomes, the probability is 1 upon 3. Incorrect. Why? classify the outcomes like this, but they are not then equally likely that one of each can result in two waves, from head on first coin and tail on second, or otherwise from a tail on first coin and head on second. This makes it twice as likely as two heads. Clear? Therefore, this is wrong. Second, if die is thrown, there are two possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 upon 2. Correct? The two outcomes considered in the questions are equally likely. Hence, this is correct. 1 upon 2. Thank you. Stay home, stay safe.